let's spend a little bit of time thinking about ions and ionic bonding. As I mentioned, ionic bonding is what you have when one atom loses 1, 2, or 3 electrons and another atom gains 1, 2 electrons. When an atom loses or gains electrons, we say that it has become ionized. It has become an ion. And you can have two types of ions. You can have positive ions, which is what they are formed when at least 1 electron is lost. You can lose 2 or 3, and we call those cations. And then you have negative ions, and those are when at least 1 electron is gained, or it could also be 2 or 3, and we call those anions. So cations are positive ions made when electrons are lost, and anions are negative ions made when electrons are gained. Typically, when you have a monoatomic cation, which is 1 atom only, those are metals. So you end up with something like, for example, sodium plus, sodium with 1 positive charge, or let's say iron with 2 positive charges, it has lost 2 electrons, or iron with 3 positive charges, it has lost 3 electrons. So monoatomic cations, when you have 1 atom only, are formed by metals. Monoatomic anions, again 1 atom only, are formed by non-metals. And for example, you could have fluorine. When it gains 1 electron, it becomes negatively charged. It actually changes name. It's called a fluoride anion. You can have a chlorine atom that has gained an electron and become negatively charged. You could have an oxygen atom that has gained 2 electrons. Look at how I put the 2 first and then the minus afterwards, because it's red. You read it as oxygen with 2 negative charges. That's why you put the 2 in front. And that means that those 2 electrons have been gained. And as all of them, oxygen, fluorine, chlorine, are non-metals. You can have polyatomic ions, which is when you have more than 1 atom. And that things get a bit interesting in there, and it's beyond the scope of this module, but I will introduce it here because you're going to come across that everywhere. And sometimes they are formed by only non-metals, but sometimes they can have a metal as their central ion, and that's always, or tends to be always, a transition metal. So for example, an example of polyatomic ion is something quite common in nature, carbonate anion. It's made with a central atom of carbon, 3 oxygens around, and it has lost 2 electrons. That collectively, that carbon and 3 oxygens as a whole have lost 2 electrons, as were the 2 minus. Or the sulfate anion, so SO4, 2 minus. So it's the sulfur is in the middle, it's surrounded by the 4 oxygens, and collectively that conglomerate of these 5 atoms, sulfur and the 4 oxygens, has lost 2 electrons. Another one that has biological and environmental relevance could be, for example, the phosphate anion, phosphates. That's a phosphorus, a central atom with the 4 oxygens, and collectively that group of atoms have lost 3 electrons. In all those examples I've given you, all those are non-metals. Phosphorus, oxygen, sulfur, carbon, they're all non-metals. But you can have sometimes that the metal, the atom in the center is a metal. And an example of that could be, for example, permanganate. And you might have heard about potassium permanganate. It's a good oxidizing agent. So there you have manganese, which is a metal surrounded by 4 oxygens, and collectively they have lost a negative charge. And another one that it tends to be quite famous is, and which a more impressive structure, is the dichromate anion. Like for example, potassium dichromate, which is again a good oxidizing agent. You have 2 chromium atoms, and those are metals. So 2 chromium metal, and the 7 oxygens around it, and collectively that conglomerate of atoms have lost 2 negative charges. let's explore a little bit more how ions, positive and negatives, are formed. And let's look first at the formation of cations. So for example, I've got here on the left a potassium atom, and potassium has atomic number is 19, so that means it has 19 protons in the nucleus and 19 electrons. So when potassium loses one electron and becomes positively charged with one positive charge, we can represent that with this equation. And if you look at here at the center of this slide, you've got the potassium, which is neutral, it doesn't have any charge because it's the atom of potassium. We put the arrow, which means reacts, to form potassium with one positive charge plus one electron. And this plus one electron means, well, it has lost an electron. Before it was part of the potassium atom, now it's not. The potassium has become positively charged. We have made a potassium ion. And it's actually called like that, potassium ion. Positive ions, cations, have the name of the atom they are made of and the word ion next to it. And if you look at what I've drawn on the right, you will see that it still has the 19 protons because nothing has changed for the nucleus. That's a potassium, that's the element potassium. The element potassium has 19 protons. If it had any other number of protons, it would not be potassium. But what has changed is the number of electrons. It used to have 19 when it was in neutral form. Now that has lost an electron, it only has 18. And if you look at the two drawings, I've tried to show how the atom shrinks. It's much smaller. It's considerably smaller than the ion, the positive ion. The cation is considerably smaller compared with the atom in its neutral form because it has lost one electron, and it's beyond the scope of this module, but that makes, not only it has lost an electron, so there is fewer electrons around the nucleus, but also it has increased the strength of that positive charge. There are fewer negative charges in the electrons trying to counteract the positive charge. The potassium ion, the positive ions, the cations, shrink considerably with respect to the atoms that are not ionized, the original element we are looking at. Let's look now a little bit about the formation of the anions. So it's possible to gain 1, 2, or 3 electrons. After that, the energy required doesn't work very well, and it's possible to lose 1, 2, or 3 electrons. And whether an atom will gain or lose, or better said, whether it will, for example, for an ion, lose 1, 2, or 3 electrons, depends on the electronic configuration and what's going to give you a more stable formation. And again, that's beyond, I'm happy to discuss this if you want to, but it's beyond the scope of this module. We've got here the example of chlorine. Chlorine is an atom that finds it quite easily to become negatively charged. It liberates quite a lot of energy. Look how I have written the equation here. I've written chlorine, which is the element I'm looking at, I've written plus 1 electron because it is gaining 1 electron. The electron here is our reagent. It's on the left-hand side of the equation. It's in the reagent side because you have the chlorine and you have the electron. You are adding that electron. And you end up with an ion, the Cl-, the chlorine with a negative charge. And we call anions change names. They end up with the letters I, D, E at the end of the stem of the atom, the name of the atom that you're looking at. In this case, we have formed a chloride ion. So positive ions, cations do not change name. You call them potassium ion, sodium ion, chromium ion. Anions change their name. They become ides, chlorides, fluorides. I've got a few names in a future slide. And I'm not really sure you can see it very well. Look at the picture on the left and the right. On the left, you have the chlorine atom. So an atom of chlorine, it has 17 protons in the nucleus. It has 17 electrons. So it's a neutral atom of chlorine, element chlorine. On the right, I've got how it might look like if that atom of chlorine will gain an electron. It still has 17 protons because it's chlorine, that has not changed. Chlorine has 17 protons and that's what it has, but it has gained 1 electron. And you might not be able to see it so clearly, but the size of the ion, the size of the negative ion is slightly larger than the size of the original atom because you are gaining one electron. So the size of the ions is different to the size of their parent, the atoms they come from. When you're forming a cation, a positive ion, the size of the ion shrinks, so cations are smaller than their original atoms. And for the anions, they are slightly larger because you are gaining one electron or two or three.